Okay, now we're going to look at least common multiple. Now, this particular phrase does tend to throw some people for a loop, but a multiple is how many copies of a number we have. They're bigger or equal to the number. A common multiple is when we have two or more numbers, a larger number that both of our starting numbers are factors of or divide nicely into. That makes that larger number a common multiple. Now, there are many common multiples because once I find one common multiple, I multiply it by 2. If they went into the first one, they're going to go into 2 times it or 3 times it. So there's an infinite number of common multiples. The least one, though, means we're going to do the least amount of work when we need to use this for something else. This comes up when we're finding the common denominator of two fractions with different denominators. So that's why we're covering this now, because we're going to be doing fractions very soon. Okay, so the book has a way of comparing the prime factors. So I'm going to write that out and kind of talk about what's going on. Okay, so So 8 and 12, 84 and 90. We picked these deliberately because they're the numbers we just prime factored. So 8 was 2 times 2 times 2. And then 12 was 2 times 2 times 3. Now in the book, what they say is when the numbers match, line them up. When they don't match, like shift it over and make a new column. So this 3 that I just put here, I'm going to erase and nudge it over a little more. Now, our least common multiple, all of the factors within a number, I need to see that many factors in the least common multiple. It's like everybody has to be represented. All right, so 8 is 2 times 2 times 2. So I need to see 2 times 2 times 2. I have to see 3 2's here for the 8 to be a factor of the least common multiple. Now the 12, I had a 2, I had a 2, so the 2's are accounted for. I don't need extra 2's, but the 12 had a 3 in it, so I also need to see a 3. Now we can double check by looking at our 8 list, looking at our least common multiple list. Does everybody that shows up in the 8 list show up in the least common multiple? So 2, 2, 2, 2, 2, 2. All right, 8 is represented. Now our 12, I need a pair of 2's and a 3. All right, I see a pair of 2's and a 3. 12 is represented. So that is our least common multiple. We didn't add any extra numbers in, or multiply any extra numbers in there. So now when we multiply this, 2 times 2 times 2 is 8, times 3 is 24. So that is the formalized way to do it. And when you get really weird or bigger numbers, it's nice to be familiar with this procedure. Now, some of you guys may have looked at this and you were like, all right, well, 12 is the bigger number. The first multiple of 12 is 24, and 8 goes into 24, so it's 24. That's fine. And it can be that little work, just a little bit of thinking, and you're there. And if you're that comfortable with your numbers, cool. But what if we get something like 84 and 90? Not as nice. All right, so let's go ahead and list out what 84 was. That was a 2, a 2, a 3, and a 7. And then our 90 was a 2, a 3, a 3, and a 5. 9 and 10, yes. All right. So the columning setup's a little weird. But 84, I need to see 2 2's. So 2 times 2, a 3. 90 had a second 3, so I'm going to make sure I have 2 3's. And then I have a 5 and a 7, so I just need to make sure there's one of each of those. So now when I'm checking 84, I saw a pair of 2s, a 3 and a 7, a pair of 2s, a 3 and a 7. When I'm checking my 90, a 2, a pair of 3s and a 5, I have a 2, a pair of 3s, and a 5. So my number is accounted for. There's no extra numbers. I just have to multiply that out, which 35 times 2 is, it's a bigger number. Two times 2 times 3 times 3 times 5 times 7. 1,260. When I'm using OneNote, if I type just a basic number calculation, it'll crunch it up for me. So sometimes I have to do that. All right, so 1,260. That is a huge number, but 84 and 90 weren't small to begin with. Now, as a little bonus, this can help some people. This can be a little confusing for other people. But I came up with this abstract example here. Now, I say abstract because I threw some variables in there. But you guys had like terms, you were talking about variables in all of your notes in the definitions. So we're going to do the same thing here. Now, when we have these weird looking algebraic expressions, and they're expressions because there's no equal sign, if we're wanting to find the least common multiple, which can happen, especially in your later math classes, you can get really weird looking denominators. The whole process still applies though. Now here though, my process, like those are the lists. Those are actually the prime factorization. They don't get any bigger because we don't know what X is, we don't know what Y is. But I need to see a 2, an X times an X, because that's X squared. And then the other one, and then a Y. And then the extra things I'm going to need, I need a 3. I already have one X. I have one Y, so I need 2 more Ys. So our least common multiple, 2 times 3 is 6. X times X is X squared. Y times Y times Y is Y cubed. Now this problem is not on your worksheet. I just made it up just to kind of show you guys this works even in the abstract sense. For some people, that makes a little extra thing click. For other people, it's like, I don't know. That's okay. If you're, I don't know, it's okay. Just ignore it. You saw it once. That's good enough for me. I just like to stretch y'all's brain as a muscle. So when it snaps back, you're more familiar with the stuff you need to know. All right. So next video is going to be order of operations.